Yo, this is Code Z coming to you today with a special screenshot Saturday tech demo of the Surface. Just a couple of features I've been working on trying to get this core mechanic pulled together for what I have in mind. So let's get right into it. First off, what is the Surface? Well, the Surface is a 3D action-adventure game where the player is going to control a colony of these human-like ants that just emerged to the surface. Now, of course, even though these ants are human-like and a little larger than you might expect them to be, of course, on their planet, they're still ant-scaled, right? And so it's going to take teamwork and cooperation and some management from the player to help these ants succeed. And so to kind of accomplish this goal, you can kind of just hear from the premise that I kind of got some large ideals for this game. So just coming in off top, there are a couple features that I needed to implement to kind of get this thing rolling smoothly the way I need it to run. So for starters, I needed a custom camera rig because with a player controlling individual ants and the ant colony as a whole, being able to fly above, the colony to get an eagle-eye view of what's going on, scout around, places where your ants have previously been, to reassess the situation, things of that nature, is necessary, as well as being able to attach to specific ants to take control of them in a third-person perspective. I also needed object pooling, right? Of course, object pooling is really something I came across in a tutorial on Unity. They had a thing about object pooling, and he did a very simple kind of like one object pooler, and I was like, yes, I know of object pooling. It's one of those things that you do once upon a time without really thinking about it, and you were like, one time I did a level drop game, with the gap in the middle, you fall through the hole and the platforms try to carry you off the top of the screen. I used object pooling for that, but hadn't had a word for it. But now thinking about this game where you're gonna have ants going up against massive creatures using their primitive ant weaponry, throwing goo bombs and all these different things, also having to collect resources around the world, resource spawns and things. I thought, well, this is a great time to go ahead and make a good Omni object pooling solution that would allow me to create and aggregate object pools for all manner of different objects in one workable script. And also, because we are dealing with ants, of course you got to deal with ant tunnels, right? Now, there's some games where, they have ant tunnels and it's just, it's either a preset area where it's just like the tunnel or the colony area, or maybe it's in 2D, where you go down and there's corners and things of that nature. Well, I said I'm doing a full 3D game. I want to be able to have full 3-dimensional tunnels, right? Customizable by the player, so that when the player walks up to say, the end of a tunnel and say, well, I want to build a new tunnel on the end of this, they can pick, well, what type of tunnel they want, how they want to orient it, how they want to position it, and have it go in all 3 dimensions, right? X, Y, and Z. To facilitate this, I needed a 3D grid system that will allow me to navigate that with the Ants AI, as well as be, customizable and immersive, and believable, really, is what I'm trying to go for. From the player's perspective, right? When the player comes in initially and they have just like a small little kind of tunnel layout, very simplistic, and then as they start to grow their colonies, they get more ants, they need more space and things, they start to make decisions about where the next tunnel is going to go, how they're going to connect, and to be able to see that growth. For me personally, I know that's a feature I like in games, so I'm thinking others would like it too, and so I had to develop a system to kind of facilitate this. So first, I'm going to talk about the Kode Cam, right? This custom camera that I made, and what its requirements were in making this. So, for my Kode Cam, I knew I was going to need it to be able to fly free, right? To allow the player to navigate around the world independently, right? Kind of in a first-person view. I also was going to need to be able to target different objects to follow them around, right? Even if I targeted an ant in its AI state to just watch it roam, or if I wanted to take control of it, in both cases I would need to be able to have my camera follow a game object, right? In a very general sense. Of course, with target following, you have, the common functionality of orbit, smooth, and zooming and clipping. right? And also I wanted to be able to target via a double click, right? So when the player is flying around in the first person, they see something they want to follow, they see something they want to target, they can double click it and immediately be able to follow that object. And then because you'll, say I'm following one ant and I need to look at something else, or I need to target something else, or I need to have a script, carry my camera elsewhere, right, for a moment and then bring it back. Most specifically, in the example of when I have the player decide on building a new tunnel system, right? The player, either taking control of an ant or not taking control of an ant, can select from the caps of the tunnel to decide that they want to place a new tunnel at the end of a given cap, right? So basically on a cap by cap basis, the player will make decisions about which new tunnel is going to go where. So when, say, an ant walks up, or a player controlled ant walks up to the end of a tunnel, I want the camera to be able to jump out off of the ant to get a full view of the nest area, allow the player to make their decision about how they want to place the tunnel. And then when the tunnel has been placed, or when the ghost essentially of the tunnel has been placed, because ants would still have to build that out, and actually, I guess you could say hollow out the ghosted tunnel, to be able to come back to the ant, right? So that's what I mean when I say target stacking, being able to, stack targets, and then as I pop them back off, go back to the previous target, and ultimately be able to return back to free flight mode from having targeted a game object. So we're going to demo that in just a second, where we're going to fly the camera around the test area, right? I have a test area laid out just to show off some of the camera flying. I'm going to follow some objects. I have Ethan, a common, Unity proto character. We're going to follow him around, show off some of that clipping and orbiting. I'm going to target and untarget a couple times. And then I have a couple of stationary objects where we're going to target Ethan and then target those, right? Both with the double click. And then I'm going to I have some of my objects in my object pooler that I just mentioned, moving around the scene. So I'm going to try and target one of those as well. Again, do some target pushing and popping just to show off that functionality. Follow the pooling objects for a couple of respawns and talk a bit about that. And then come back to the inspector to show when I'm popping those. In the inspector, you'll see when I'm popping my targets off, you'll actually see the target list shrinking and growing as I add and remove targets. And when there are no targets, I'll go back to free flight mode in the first person. So let's jump off a moment and check out that Kode Cam. So here you can see our scene. I'm kind of placed my camera above Ethan here. Right, I have just some of those proto walls and a proto floor set up. Kind of did like a little maze thing here. Obviously having way too much fun with it. So looking at the Kode camera, you can see our custom spring arm cam script. That's what I called it. It's kind of like a spring arm rig, game object pivot camera setup. Here you can see in the hierarchy, game object pivot camera. And I'm going to set my scene view to go ahead and follow that camera as we move it around. So here we can see I'm in the first person cam, and I can fly this all around. I have left to right strafing with horizontal axis, forward and backward with the vertical axis, and also put in an extra axis elevation for up and down vertical moving. So something very similar to the Unity scene camera. Right, that was something I was going for. And again, developed by scratch, I kind of just took it use case by use case and said, okay, what do I need? And then kind of built it in. What do I need? Built it in. So here, we're going to see some of that targeting. As you can see in the scene, I use ray casting from the camera to the target. And then these debug lines you can see are from the pivot point placed at the center of the bounds of his renderer object, of his renderer component, to the four corners of the frustum of the near clip plane. I went out by about 10%, so here you can see it's 1.1 from the viewpoint to world point conversion. and then negative 0.1. So like I said, about 10% out, just to kind of smooth on the clipping when I'm coming in, right? To try and prevent, you know, when I'm coming towards the wall, to prevent it from going, you know, too far too fast. Or to prevent it from clipping into the wall by running into it too quickly, right? I give myself a little buffer so that I can get away from the wall faster than it would clip in. So here you can see we follow the character by, you know, a moderate distance. I can use the scroll wheel, zoom in and out. If I zoom out here, as you can see, it tries to zoom out and it hits the wall. If I carry it along the wall, you'll see how that clipping pushes from wall to wall and then reachieves its pre-cull distance. So if you look in the game view, you can see it's a pretty smooth, you know, clipping in and out, in and out. And then of course in the scene you can see, you know, how it kind of smoothly transitions in and out. I can change the, you know, desired distance and it'll move in and out pretty smooth. I'll double click on this sphere, right? And so you can see we jump targets, but currently it's just mapped to F, but of course I'll have it mapped to other keys as I develop the full game input and, you know, axes and things like that. With F, I can jump back from targeting the sphere to targeting Ethan. So, you know, to the sphere, jump over to the cube, back to the cube, back to Ethan. Alright, I'm just moving all about. Let's see, I'm going to try and grab one of these pooled objects. I'll probably have to zoom way out. And bang. So I caught one of the pooled objects, and as you can see, we're following that as it moves up and down. They just have a very simple script that, you know, pops them into the world on enable and then fades them out, and they fly around. Right now, because we have a fairly low spawn rate for the capsules, we'd have to wait a while for that one to get re-enabled and spawn back into the world. As you can see, it took a little while as it, you know, ran through the pool, essentially from the top. Each one that goes inactive, we pop it back in, pull it back in. So now that we've seen a bit about the cam, like I said, fairly simple cam so far. Really just doing essentially the bare minimum of what I needed to do. You know, clip, follow, some stacking. I thought it was pretty cool personally. So now we're going to jump back over to check out the object pooler. All right. So talking about the object pooler, right? Like I said, I had seen a tutorial, you know, about object pooling, and I was like, oh yeah, I know object pooling, I can do that. Object pooling, for anyone who doesn't know, is for the reuse of frequently instantiated and destroyed game objects. A lot of times, if you're doing things like grenades or maybe projectiles that aren't hit scan, you know, a common, I guess you could say, attempt you might make, or a common approach you might take, is to just instantiate and destroy. Instantiate and destroy. You need it, you make it. When you don't need it no more, you destroy it. But object pooling allows us to be more efficient and conservative with our memory, and, you know, not taxing garbage collection and things of that nature, by just deactivating, right, and then reactivating, right, enabling and disabling, as opposed to instantiating and destroying, right? If it already exists, you just turn it back on, reset all of its parameters, right, move it into place, whatever you need to do, and then send it back out into the world. You can also, you know, pre-initialize pools to, you know, during load time, to cut down on load times in game. You don't want lag spikes and things of that nature. So besides just doing basic object pooling, I wanted my object pooler solution to allow multi-object pooling, right? So that, say if I have a character who throws grenades, or 10 characters who throw grenades, instead of giving each of them a pool to throw grenades from, I have a universal pool, maybe 100 grenades, and each of those 10 people can, you know, throw as many grenades as necessary, without anyone ever, you know, going for a grenade and it not being there. But at the same time, managing the overhead of instantiation and destroying over and over and over and over. I also wanted to be able to have singleton access, right? So essentially a static game manager type of object that all of my classes can call to when they need a pooled object, right? A commonly instantiated or destroyed object. Like I said, when I'm dealing with resources placed around the world, you know, a little stack of rocks here, some food here, twigs there, wood, things of that nature. If they're going to be randomly dropped around the world, I don't want to have to keep instantiating and then destroying them when they're harvested. I can just activate and reactivate, deactivate and reactivate as needed. Also, when, say, I have a spike of demand, right? I run into some enemies and everybody's throwing grenades and it's getting ridiculous, and I increase the pool, right, to maybe 50, when on average, or on the base case, I really only need 10 pooled grenades, right? But because I got into a high demand situation, I had to increase the pool size, you know, to meet equilibrium with the demand. But now that I'm out of that situation, I'll want to pull it back down. Being able to do that from a static object allows me to reduce all the pools universally as necessary. And like I was mentioning just now, being able to grow and shrink for, you know, spikes in demand. Also, I wanted to be able to create initial pools from the inspector, so I kind of just added that in there with a couple of, you know, public fields, and, you know, it does like a instantiation on awake, I think it is, or start. I forget where I put it. You know what I'm trying to say. So, to demo this, like I said, we're going to take a look at the pooler test script that I wrote. And the test script is just, like I said, a secondary script outside of the main object pooler that uses it, like I said, from its static context. And also there's the shrink from existence. You already saw it in action where, you know, these things, they just kind of bob up and down. I just gave them some random motion, you know, threw a sine wave on it and called it a day. And then slowly just shrink out of existence as their lifetime depletes. And when their lifetime depletes, they disable themselves instead of destroying themselves. The pooler test script reactivates them and places them in the world at a different position so that they can, you know, continue to do their up and down and shrinking thing. We're going to look at the initial pools in the inspector, right? Like I said, I can set up pools at runtime, or I could set up initial pools as necessary. We're also going to run one time with the pool growth option off, right? And then we're going to turn it on, and I'm going to show essentially a demo in spiking the pool growth, right? Spiking demand, and then shrinking it back down to reduce the pool once that demand lowers. Right, so let's hop over to that. Boom. So, looking now at the object pooler, right? On my object pooler, right, this would normally be, you know, a manager type object, and this pooler test would be off on another script. I could have put it on another object, but it, you know, just wouldn't have made much difference. It had just been, you know, too many objects floating around over in the hierarchy for our test. But do know that this pooler test is not maintaining a direct reference to this object pool. It's not doing a get component or anything of that nature. It's accessing it statically. All right, so we're going to take a look at that. In just a sec. So here we can look at our pooler test. Like I said, it just has a list of game objects that it wants to pool, the amount of objects it'll pool per object, whether those pools are allowed to grow or not, and then a float for how often do we want to spawn a new object, right? How often are we requesting one of those new objects? So the first thing we do is we go to our object pooler, and we, for each of our game objects in our list, our public list here, we want to add that list to the pool, specify or create a pool for that object, specify how many objects it should pool, and whether that pool is allowed to grow. All right, so not necessarily a constructor, but it's a, what do they call it, factory, builder, something like that. One of those nice design pattern names. And then on update, of course, we just decrement our spawn timer. Once it hits 0, we get a pooled object from our object pooler. We get our pooled objects by name. If that name does not exist, it'll return a null game object. That means if I requested a pool for an object that I wasn't pooling, I'll get a null, right? I can use that to say, oh, well, if I requested an object for an object I wasn't pooling, then let me make a pool for it, right, if necessary. And I can have that happen as well. Also, if I go for a pooled object and I haven't allowed that pool to grow, then I won't get an object back as well. So I'll get a null in that case as well. So, of course, playing it safe, checking for the null. And then once I have an actual object, I place its transform in a random place, about 10 feet, 10 Unity units off the ground, and I set it active to true, right? When I hit the letter P, I'll run shrink pools, right? So that's all this script is doing. Like I said, very simple. It could be any script, it could be anywhere, it could be anybody making these static calls to the object pooler. Then I have a couple of prefab objects that just have this shrink from existence script on them that, give them a certain lifetime. I boosted it up to 10 in the editor, but it's whatever. A remaining life private variable, get their own rigid body and origin and target and blah, 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 so that they can, basically, whenever they're enabled, reset their origin, pick their new target, which is just 10 below their origin, and then linearly interpolate, on sign just up and down from, their target to 10 below their target. Like I said, just some random movement script that I threw on there just so it would, bob up and down. That's all I was going for. And when that remaining life is equal to 0, instead of destroying, you see the key is that we're just setting it inactive, right? Set active to false. Like I said, the object pooler is keeping track of who's active, who's false. If you go active, I can see that it's active and, pass it to the next request for a pooled object. And I'm just doing that. I'm using a dictionary, basically, of the object names, and then it links to a pool. Is it struct? I think I made it an actual class. It's a class for the pool used by the object pooler. And so the object pooler keeps a dictionary of pools, and the pool class has its own set of methods that work with the object pooler to retrieve objects, do things like shrink and grow and all this other stuff. So, jumping back over to Unity, we're just going to see how the object pooler does its thing here, right? So here we didn't initialize any pools. That's why you see it says init pools. If I had decided to make any init pools in here, it would have been as simple as giving it a pool object, deciding the pool amount, deciding if it will grow, right? But that would have been direct from the object pooler, meaning that, say if from a game manager perspective I wanted to have initial pools that loaded on game start, I could put those pools in here. This is an example of a runtime pooling, right? So after the game started, the very first thing that this pooler did was say, give me a pool of pool capsules, give me a pool of pool cubes, give me a pool of pool spheres. Give me 10 of each and let each of them grow, right? This pooler test is spawning one of these objects every, 2/10 or 1/5 or however you'd like to call it of a second, right? And right now, right, if you were to do the math, you'd realize that 2/10 of a second times 10 wasn't going to give us enough objects to pool consistently, right, to meet that demand. So if I scroll down here in the hierarchy, you can see the 10 pool capsules first, right, then the 10 pool cubes, then the 10 pool spheres, but then, right, and also it's rotating. If I hadn't mentioned that before, it's going 1 cube, 1 sphere, 1 capsule, 1 cube, 1 sphere, 1 capsule. You can see the overhead where it said, well, I got to meet equilibrium, so I had to acquire this many more pooled objects, right, because we are allowed to grow. Now, if it wasn't allowed to grow, there would be a segment where the spawning would have to stop and wait for these pooled objects to time out to allow us to pool new objects, right? So if I were to turn this off back over here, if I say don't grow, right? And I could put the spawn time, you know, super low if I wanted to. I could take it all the way down to, say, 0.1, right? 0.01 even, right? Spawn as fast as you can. So you'll see, boom, as soon as we come in, it dropped all those objects in real fast. And you see they're all up and down in, but because it can't grow, it's limited to that 30 objects, right? The 10 capsules, 10 cubes, 10 spheres. And as soon as they go inactive again, he's ready to pull them back in real fast. All right, let's watch it. Pulls them right back in. So, let's say I do allow them to grow, and I leave that spawn time really low. Initially, I only gave them 10 objects per pool, right? But I hit this point in time, or let's say, you know, let's do a spike. So, I started off at about half a second. So, it'll spawn one object every half a second. Oh no, that's not half. Not half at all. Half a second. It'll spawn one object every half a second. Right, and you can see it just slowly adding one to each of these, right? One capsule, one cube, one sphere, one capsule, one cube, one sphere. Right? But because they're timing out in 10 seconds, you can see the bottom 3 capsules don't actually go inactive because one of the previous capsules will deactivate before it gets down to there. Right? Boom, bam. And deactivate and get woken back up on the next request for a pooled object. Right? So let's say this was, you know, standard demand. I might run into some where, you know, I maybe get 1 or 2 more. Right? But then let's say demand gets really high, really fast for who knows what why reason. And let's say I take the spawn time down to 0.1. Right? So now you can see we maxed out our initial pools and we started having to add more, right? We had to instantiate on the fly to increase the size of our pools to reach the new equilibrium. Right? So right now we've reached the new equilibrium and everything's looking good. You see we have this block of inactives, you know, they slowly travel down, and as things are, you know, not needed, we pop them off, push them down, pop them off, push them down. Right? So now we've reached a nice equilibrium here. Right? Every time one is requested, there's one available, which is good. Right? Now let's say that the demand, it goes back to normal, 0.5. Well, now we have a whole lot of objects unnecessary. Right? All of these objects that are spawned but are not needed. So now we're back to roughly 7 or so of each of our initial pools that actually was necessary. So to get rid of all of these, like I said, we have the P key that'll shrink all of our pools. When I hit P, it'll shrink the pool back to whatever the previous pool amount was, right? So our pool amount was 10, it shrinks it back to 10. Nice. So that's essentially, you know, what I've been up to past week. Working on these different game features to facilitate, like I said, a lot of the core mechanics and different features that'll be present in the Surface as the game is developed. These are some of those core features that I was going to need. So, last but not least, certainly not least, because this is where it gets cool. This is the cool stuff, ladies and gentlemen. In just a second, flip back over. Okay, so this is where it really gets nice here. Because now, I know you see the picture, right? Let's just talk a bit about what we're seeing here in the picture. Here in the inspector, we can see, you know, there are different available grid cells, right? We're going to talk about those available grid cells. Here we can see just a scene from our camera being inside one of these tunnels. I had to put a light on the camera so that we can go through. You know, I could have lit the tunnels, but of course it's much more interesting when it's not lit. Just watch what I mean. And then you can see here, I have, you know, this really broad top area going deep into this bottom area, and as you can see, it's like 1, 2, 3, 4, 5, 6, 7. I think this was the 7 by 7 by 10 deep, right? And you can see here in the console the indices, right? Because I'm using a single array index kind of translated into a three-dimensional matrix. So I'm using a single dimensional bit array translated into a three-dimensional matrix to essentially represent this grid system, right? So let's talk about it. This 3D tunnel grid system, right? What were my requirements? What did I need? Well, I needed a three-dimensional matrix that I could later navigate with an A-star search, right? I'm going to try and do some pathfinding and things, you know, those cool things we learn in AI courses, right? And to do this, I need to maintain a world-oriented, navigatable representation, right? Which means I need my, you know, X to always be X, my Y to always be Y, my Z to always be Z. But like I mentioned before, I'm going to have, you know, the tunnel system be fully customizable by the player, meaning that they're going to be able to take maybe an L tunnel and turn it, whether they wanted that L tunnel to go up a level, down a level, to the left or to the right, or, you know, rotate it on its Y-axis to turn it around and connect it in different ways. I needed to make all of that possible while still maintaining a navigatable space, meaning that, you know, from space, you know, X1, Y0, Z2, can I go down to X1, Y1, Z2, right? And down needs to maintain a consistent direction. I also needed to maintain some independence from the actual tunnel meshes, which means I wanted to design the grid cells in such a way that the only concern was which tunnel cell, which grid cell they could connect to, right? Not to be so rigidly constrained to the mesh, because if I ever wanted to change the mesh or change how the mesh was designed per se, right, I didn't want that to, you know, make me have to rewrite my whole tunnel script, right? Good code design, that's what I'm going for, right? You know, loosely coupled modular code design, nice. And I also, like I said, wanted full customization of the tunnel layouts. So just to talk about it, I'm going to show you a 3x3x3 tunnel system, right? Now, when I say 3x3x3, the X and Z axis are my width and length, and then my Y starts at 0 on the top and then goes down, right? So I guess you could say the top left corner would be 0, 0, 0, and you're going to see it as it's built out. Now, the tunnel system is always going to start with its root entrance in the center. And that was something I wanted because me personally, I'm a fanatic about symmetry. So being able to have, you know, a 3x3 grid with the entrance in the center just seemed the most appropriate, right? Everything being fairly equidistant when you start setting up your tunnels. Now, say, you know, after a couple of, you know, you play through the game a bit and you want to expand. You might not expand symmetrically all at once, but I wanted so that on each expansion, whether you went one in the X direction, one in the Y direction, one in the Z direction, to maintain that relative centering of the grid, which took a little math wizardry to, you know, properly adjust to recenter the smaller three-dimensional grid inside of the larger three-dimensional grid and transfer over those connections in the bit array. Because again, like I said, using a bit array, which is still essentially like standard array, holding single character bits and transferring that over. Because really each bit is just saying that the grid space is occupied or not. Once I know it's occupied, then I get the actual tunnel cell up under it and just find out by its tunnel type which direction it can connect to. Cool stuff, man, cool stuff. Then I'm gonna, you know, end the play and I'm gonna reinstantiate it at a 7x3x7, right? We can check that out. And then I'm going to show how all the tunnels can rotate, as well as maintain, right, their knowledge of which directions they can connect to, right? When they turn their connectors, I guess you could say, their grid cell connectors say positive X, positive Y, positive Z, negative X, negative Y, negative Z, right? In a sextuplet, if you will. And then, you know, doing some bit shifting fanciness, I can judge between two cells whether two adjacent cells, whether they're actually connected. It's fancy stuff, man. Fancy stuff. I love it. Right, and then we're going to go into these tunnels with the Kode Cam, and it's going to be so nice. So nice. Oh, it's nice. All right, let's check it out. So, I'm going to deactivate this test area. Activate the proto test area. All right, again, we're going to come over to the camera. Now, for just a moment before we, go into running through the tunnels, I'm going to go ahead and I'm going to turn the camera down just so it's more well lit. I'm going to turn the directional light down so it's more well lit and we can check it out. So, a 3D grid system. Right now I have it building via coroutine. So when you see it build up, it kind of trickles in. Right? Because when I do the scaling, I did a 20 by 20 by 10. That's what you saw in the picture, right? The first 2 layers of that 20 by 20 trying to go 10 deep. Way too big. More space than anyone will ever need, but I invite you to try it when the game comes out. I invite you to try it. So here we can see, like I said, a 3 by 3 by 3. Right? 3 wide, 3 deep, 3 high. And it just randomly selects from the available tunnels and just drops them in. Right? As I rotate, right now it's just programmed to 1, 2, and 3 on my keyboard. So if I hit 1, everything rotates on the x-axis. 2 on the y-axis, 3 on the z-axis, z-axis. I'm not in Britain. I don't know why I said Z. I watched too many tutorial videos from over there, obviously. And then at any point, if I hit 4, it'll show the debug lines for the orientation, right? And the orientation is not based on the tunnel. The orientation is based on the grid system. The grid system says, what connection should I have on this tunnel system? And that, again, took some math wizardry to properly correlate, based on the rotation. Of course, whenever you rotate on the x-axis, Y positive goes to Z positive goes to Y negative. So, just doing those types of transformations in the connectors tuple to maintain that rotation. It was fun stuff all around. So now I'm going to move the X limit up to, say, what did I say, 5 by 4 by, Y would be 4 by 6, right? And here I'm going to rotate, get that proper entrance tunnel, right, laid in. And then I'm going to hit R to resize, and you're going to see it, again, via coroutine, just run them down. So, again, it didn't overwrite the tunnels in the middle. It copied the tunnels centered, right, relatively centered, because we have an odd number this way, but an odd number on the x-axis, but an even number on the z-axis, so it had to adjust that 1 over. But if I take it up again 1 more, it'll just readjust on the resize to the other side, right, to recenter our center entrance. Like I said, it just felt right to me. It just felt right. Right? So bounce back out. We can scale it up to a 7 by 7 by 3. Right, watch it do its thing. Oh wait, I put the 7s in the wrong place. See, what it did was 3 by 7, 3 by 7 by 7. I actually put the height at the bottom. These are probably not the most appropriate variable names now that I think about it, because it's like width, length, and then height being last. Should probably just go ahead and switch that. All right. Width and height 7 with a depth of 3. That's what I was going for. And trickle those in. Nice. Right. Right now the tunnel caps, they use colliders. So say if I'm inside this tunnel, when I rotate it, you'll notice that the collider, reactivates itself and then deactivates when it collides with another cap. So when two caps are touching, they deactivate each other, or deactivate themselves, essentially, not each other, but deactivate themselves, allowing it to become an opening. It was just a, you know, fast and dirty way of accomplishing the goal, really. But once I make the tunnels, you know, more aware of each other, then I'll have them activate and deactivate their caps. But again, that would still be fairly tightly coupling the tunnel meshes to the grid system, which is what I'm trying to avoid. By just saying, hey, if two caps are touching, get rid of them, it's more fluid in implementation. And because I don't expect, you know, grid systems to just be turning and flipping all of their tunnel cells at once like I'm doing here in the demo, it doesn't actually cause much overhead in the long run. It's actually quite efficient. Beautifully so. Beautifully efficient. Alright. So, now I wanted to get into that more interesting part. I'm going to turn this light back the other way and darken out these tunnels. And let's have some fun with it. Alright, so this was the scene I was showing before when I said it gets really cool running through these tunnels in the dark. Because even though I know I haven't built any game mechanics into these tunnels, that ant gets me every time. I haven't built any adversaries into these tunnels, and they're very tackily textured and materialed. It is still ominous walking through these tunnels into this pitch black darkness. Maybe it's just me. Maybe, you know, it's that latent fear of the dark just coming out. You know, you get to these weird left-right points and you're like, which way do I go? Dive, man, dive, dive. Yeah, so of course, once the ants have properly inhabited these tunnel spaces, they'll be able to install torches and lights and things of that nature, make food rooms. Right now, it's, you know, very creepy, ominous, and interesting. Yes. Just any moment now, I feel like something could jump out, but I know there's nothing here. I made this world. I know there's nothing here. It's still very eerie. Turn the tunnels a couple of times. Make new avenues of escape. I doubt I could find my way back to the ant now, because I'm securely lost in these tunnels right now. And if I do, it is going to scare me like it does every time. But yeah, this has just been my little tech demo, and you know, I'm hoping you guys like it. You know, like, comment, subscribe, all those nice things. Check me out on Twitter. Check me out on Instagram. You know, follow me on all the socials, and let me know what you think.